Okay, hi everyone. So today in the EECS 1011 class, I spoke about an example of a ball falling from the top of a building, and the question was, how far has the ball traveled when it reaches a velocity of 10 meters per second? And this equation was given: distance is equal to velocity squared over 2 times the acceleration due to gravity. And I don't know about you, but I get a little hesitant about when a prof gives me an equation and says just accept it. Sometimes it'd be nice to know, if that truly represents what's going on. Well, there are different programs that you can use to examine whether or not this is actually working in terms of physics without actually knowing how to derive the equations from scratch. Simulink, which comes with MATLAB, is one. MapleSim is another, and there's a variety of other programs out there. I'm going to use MapleSim to show you how to do that. Okay, so this is MapleSim right here. It's a graphical interface for doing physics and electrical and mechanical kind of simulations. I'm going to go over here and choose multi-body components. I start with a fixed frame, which represents sort of a fixed position in space. I'm going to use a fixed body. This is going to represent the ball. The ball itself has a mass of 1 kilogram. And I'm going to add a joint between both this ball and the fixed frame, so the top of the building basically. And that is found, I will find it, joints in motion right here. So this is for the multi-body. I want prismatic, which is a straight line or linear kind of connection between two things. I'm going to join up the ball to that prismatic joint, and I'm going to hook up the fixed frame to the other side of this sliding or prismatic joint. From there, I am going to add on a distance sensor, which I can find in 1D Mechanical. It's right here. I want a translational sensor. I want one for position. So I'm going to take this one right here. It's a position sensor. I'm going to hook it up to the end of that prismatic or linear or sliding joint. And I want a velocity one. I want, let's see, where's velocity? Speed sensor right there. Okay, so I have a speed sensor. I'm going to attach to that same connecting point right there. And I'm going to add a probe to both the velocity sensor or the speed sensor, and I'm going to call this speed. And I'm going to hook up one to the position. Probe 8 is now going to be called position. And because we're dealing in metric units, position will come out in meters and speed will come out in meters per second. All right, so I got my sensors, I've got my 1 kilogram mass, I have my sliding or linear joint, and I have basically the top of the building, my fixed frame. Now what I'm going to do is I'm going to go to settings. I'm going to set my simulation to run for 2 seconds, like that, and I'm going to run it. So I'm going to hit the run simulation right here, F5. Simulink is going to run through it. And it didn't move. Well, that was anticlimactic. Let me try again. What did I do wrong? Oh, right. I did something wrong. Okay, so this prismatic joint has 3 potential axes in which it can move, X, Y, and Z, represented by this vector right here, 1, 0, 0. The 1, then 0 represents how this sliding joint is in the X or horizontal axis. I want it in Y, so I want 0, 1, 0, which is in the direction of gravity. So I'm going to try that again. Run it. Bingo, there we go. Okay, so I have my animation. That's the ball right there. I'm going to zoom out a little bit. right there. I'm going to hit play, and we're going to see it drop. And it fell. Excellent. I'm now going to move that over. I'm going to rewind back there, and I'm going to rerun that simulation where the ball is going to drop, and I'm going to see how the position changes and the velocity changes over time. I'm going to run that again. You can see that blue line tracks the progress of both speed and position. I'm going to use the slider right here to back it up. Okay, so we're going to go back in time. And what I'm going to look for is for when, let's see what the problem said originally, when velocity is 10 meters per second. So I want speed to be minus 10 meters per second. So basically right there. Let's progress. Right there. Now I'm going to get the value for that position right there. So I want probe information. I want cursor position. I'm going to go over there. And look at that. So when we are at minus 10 meters per second, so we've dropped, and we're dropping, and we've hit minus 10 meters per second, which is 10 meters per second downwards. It says that the time value is 0.975, or about 1 second. If I go over here to my position value, and I bring it over to 1 second, it says that the velocity is approximately, the position, not the velocity, the position is negative 5.235 meters, roughly, give or take. So we know that based on what the simulation is telling us is that when you get to about minus 10 meters per second, you should have a position of approximately 5 meters. And there you have it.